Okay, right. A beam AB, mass 20 and length 3. Smoothly hinged, right. So this is, yeah, lovely. C, A, B. First thing we're going to want to do is start labeling stuff, isn't it? So you want to draw the picture down for sure, and that's 1. Okay. It's a is it a uniform beam, uniform rod, and the rope is modeled as a light inextensible vert. The beam is okay, uniform, yeah. So the weight of the beam, which is 20 G, and that's 1.5. That's 1.5. This is going to be a moments question, isn't it? This is a moments question. We've got the tension in the rope. So if you imagine the tension is going there, isn't it? And it's also going there. Tension. Okay. What other forces are there? There's going to be a reaction on the wall, isn't there? So the beams. Okay, the beams holding the rope is fixed to point C on the wall, which is basically about A. The other end of the rope is fixed to the point D. Beams at the angle A, C, D is 30. Shown in figure 2. The beam is modelled. Okay, fine. So what other forces are there? There's going to be some reactions here. Okay, so tension's pulling us this way. So let's say there's going to be a reaction at A going this way, and there's going to be a reaction of A going this way. Vertical reaction and horizontal reaction. Right. The direction of the force exerted by the wall, the beam of A. So that's part B, isn't it? Okay, so part A, what have we got? So if we look at the beam and we resolve forces going vertically, we've got RA plus that in there is 60, isn't it? So if we break that into components, we've got that's opposite, so T sine theta. Do we know what theta is? 30. T times 60. T sine 60, because it's that way. Okay. Because if that's 30, then that's 60. Angles in a triangle add up to 180. Plus T sine 60 is equal to 20G. We've got that. How else can we get an equation for that? If we take moments about A, then can we be even cleverer, more clever about that? Let's have a little think about this. Break this. Okay, let's have a little look at this. If we break this tension into this way, which is opposite 30 is going to be T, so it's the same as that, isn't it? So sine 30, and then going this way, we're going to have T cos 30. Okay, now when we take moments about A, okay, and also this one, when we break it, this was T sine 60, and going that way, we've got T cos 60, and that distance. Okay, we're going to need this distance in here as well, which is going to be let's hypotenuse opposite 30, so that's just going to be sine 30, that distance there. Okay, but anyway, so the force is that one goes through the pivot, okay, as does that one. So we're not interested in that force, and we're not interested in that force when it comes to taking moments. So moments about A in a clockwise direction. So what's going clockwise? We've got the t sine 30 times by that distance there. So that distance there is going to be 1 cos 30. So just cos 30. So times cos 30. Okay. That's going in clockwise direction. This is going in a clockwise direction as well. 20g times that distance there is 1.5. And that's equal to t sine 30. T sine 60 times by that distance there. That distance there is sine 30 times sine 30. In fact, we don't need this one. We just need this one, don't we? So, well, let's hope that this one's bigger. Should we just let's put this in the calculator? So we're going to want angle unit degrees. So sine 30 times cos 30, which is... okay, so 0.438t, I'm sure there's a nice way of doing this, plus, when we simplify this, we're going to get 30g, which is 294, is equal to sine 60 times sine 30, which is, let's make sure we got that right, yeah, root 3 over 4. Let's just try that again. Sine 30, I'm just going to double check, times cos 30. This is root 3 over 4. Oh, God. No, something's gone wrong. Something has gone wrong. We don't want that there, do we? We just want to take moments about A. Right, I'm going to get rid of this tension. Just use this tension. Let's see what we get. Moments about A. So if we... this one, well, we can kind of ignore, but let's try that again with just that one. So we're going to get t sine 60 times sine 30 is equal to 20g times 1.5. So t root 3 over 4 is equal to 294. Okay. So we're going to get t is equal to 678.96. Explanation to follow. And then part B, the direction of the force exerted by the wall on the beam. So this, okay, so what we need now is RA horizontal. So let's say RAH and RAV. That's what we're looking for here. So we know. So for B, how are we doing for space? Fine. RAH is equal to this one, t cos 60, and we know t, so that's equal to 678.96 times cos 60, which is equal to times cos 60, 339.48. We need RAV, the vertical one, and this time we do want to resolve vertically. That would be RAV, right? And we've got that, actually we've used that already, haven't we? So RAV is equal to 20g minus t sine 60, which is equal to times sine 60. So it's 20 times 9.8 minus answer. That's a RV is equal to minus 392. That's fine. It's fine. So that means I presumed it was going up. It's actually going down. Okay, so the wall's pushing it down, which makes sense because the tension's pulling it up, so the wall's going to be pushing it down. Happy with that. So what do we want? The direction of the force. So we've got this, haven't we? We've got RAH and RAV, and we're looking for the direction theta there. So what we've got is 33 339.48, and we've got 392, and we're looking for that angle there. Direction, that's just direction. Okay, so theta is going to equal to tan to the -1. How are we doing for space? We're okay, aren't we? Opposite over adjacent, so 392 over 339.48. So theta is equal to times 1. Okay, shift tan. 392 divided by 339.48. Okay, 49.1 degrees, and going from a horizontal in a negative direction. Okay, them answers.